Hello, welcome back to channel Apna Tutors. So in today's video we are going to do more questions from exercise 1.1 and we will try to finish it as soon as possible. So next question is question 9. So what is given? So that for the each of the following relation R in the set A set is given integers from 0 to 12. Given by first question R is given as all pair a comma b such that modulus of a minus b is multiple of 4. You know that in the previous video, if you had watched, you should watch it, you would clearly get it that what we were doing in that question. We were had that modulus of a minus b is even. What does this even means? Even means multiple of 2, right? So in last question we were having modulus of a minus b multiple of 2, and in this question we are having modulus of a minus b multiple of 4. That doesn't change much, right? Only number got changed. So same answer you can follow it up here by changing 2 to 4 or else changing even to 4k. Nothing will change much. So you can go to that video and watch it to solve the first part. So I will do second one. What second one is saying? That R is having pairs a comma b such that a equals to b, and we have to show this is equivalence relation and find the set of all elements related to 1 in each case. This is 1, okay, related to 1 in each case, okay. So let's first show that is an equivalence relation. So for that it is reflexive. Why? Because a comma b will belongs to R as A is equals to A. So we are done with reflexive, which implies reflexive. Now why it is symmetric? AB belongs to R implies A equals to B. This implies B is equals to A, which will imply B comma A belongs to R, which implies symmetric. Right? This is easy. That's why I am doing very quickly. AB belongs to R. Now let's show transitive. AB belongs to R, BC belongs to R, which imply A is equals to B and B equals to C. B is equals to C. This will imply A is equals to C, and this will imply A comma C belongs to R. This imply it is transitive. So are we done? Yeah, we had shown reflexive, symmetric and transitive. So the relation is equivalence. Now what further is saying? We need to find set of all elements related to 1 in each case. Okay, so let's find how many elements related to 1. This is what, if you know, I had in introduction video I had given the definition of equivalence class. When the relation is equivalence, for every element from the universal set we can find equivalence class. What does that mean? That equivalence class of 1 will be having all B belongs to R such that 1 and B are related. This is the definition of equivalence class, which is what written here. Set of all elements related to 1. Set of all elements related to 1. Right? So we need to find this. What does this mean? B belongs to R. 1 comma B belongs to R means 1 is equals to B. That is the definition of relation. This implies what is the possibility of B? Only singleton 1. So set of all elements related to 1 is only 1. So we are done, right? Yeah. So we are done with this question. Next question is, given example of relation which is symmetric but neither reflexive nor transitive. This is very easy part. You just have to play with numbers. This you can do as a homework, because now we had did various questions related to reflexive, symmetric and transitive. As I don't want to waste again time in these questions, I will do some important questions. Okay, so let's move forward. This is your homework. You just complete it. This is very easy. Okay, so let's move to this question. Yeah, this is a very important one. Even this can be asked in boards in 3 to 5 marks. This question is very good. Okay, so what is given? So that the relation R in the set set A of points in a plane. So our universal set is set of points in plane, and relation is given as pair of all p comma q such that distance of point P from the origin as the same as the distance of point Q from the origin. We have to show this is an equivalence relation. Okay, let's do till here, then we'll do further part. First of all, let me explain you what does this relation mean. What is universal set? Set of points in plane. Okay, so plane means coordinate plane. This is x-axis, this is y-axis. All points are universal from set A. Set A is all of these points. Okay, now what is relation? How two elements will be related? If their distance from the origin is same. Suppose I am having one element here and this distance, and suppose I am having one element here and this distance is suppose same. Yeah, it's not looking same, but you just get it what I am trying to say. Suppose this is P and suppose this is Q. Then P and Q are related if OP equals to OQ. This is what the definition here relation, so definition of relation means. Okay, now I think you got the definition of this relation, right? So we have to show that this relation is an equivalence relation. Okay, so let's do. So what will be first? First is reflexive. Reflexive we have to show for every A belongs to little a belongs to capital A. A comma A should belongs to R. So why it will belongs to R? Because we know as A belongs to A, then distance of A from origin is same as distance of A from origin. I am writing again, but that's what we wanted, right? That by that only we can say that A comma A will belongs to R, because A comma A will belongs to R when distance of A from origin is same as distance of A from origin. Yeah, so we are having it is reflexive. So next we will show symmetric. Suppose let A comma B belongs to R. What does this mean? Distance of A from origin, this is A from origin, is same as distance from B to origin. But this also means that distance of B from origin, writing A from origin first, writing B from origin first doesn't matter, right? Is same as A to origin. You just fill these gaps. Okay, so this is what we wanted, right? That if distance of B from origin is same as distance from A to origin, that means that B A belongs to R, because that's what is the definition of relation given. So it is symmetric. We had shown because we had taken arbitrary AB from R, and now we had shown that BA belongs to R, so it is symmetric. Similarly, let's show it is transitive. Why it is transitive? So let A comma B, B comma C belongs to R. What does this mean? Distance of, and what we have to show? You should know what you want to show and you should know what you have, then your work will be quite easy. So then distance of A from origin is same as, I will write it as OA directly. Okay, you just understand, when you are writing in exam you should write it in this sentence form. So distance from origin to A is same as distance from origin to B, and distance from origin to B is same as distance from origin to C. By this can I say that distance of origin from A is same as the distance of origin from C, and this means that A and C are related, right? And this means that our relation is transitive, because we had taken arbitrary A comma B and B comma C from R, and we had shown that A comma C belongs to R. So relation is transitive. So we had shown reflexive, then symmetric, then transitive, hence our relation is equivalence relation. Now let's do further part. Further, so that the set of all elements, all points related to point P, which is not origin, is the circle passing through P with origin as the center. Okay, first I will show it diagrammatically so that you can get intuition what they are trying to say. They are saying all points related to P. Suppose I am having some P not equals to 0. Okay, when will some element will be related to P? If its distance, this distance is same as that, suppose I am having other element which is related to P is here, and suppose then this distance should be same as this distance. Okay, so they are saying set of all such elements which are related to P will form a circle. Why? Because suppose now I am taking it here, now this same distance if I am taking points and so on. So at the end this will form a circle. Yeah, I know my diagram is not good, but you just understand what I am trying to say, that you got it right. When you are taking all points which are equidistant from the origin, having distance same as OP, then it will form a circle. And okay, so they are saying this only, that we have to show this. Now let's show it algebraically, how we will show this. Okay, so suppose I am writing set as S. It contains all points. Suppose I have fixed P. This P is fixed. This P is fixed. Any arbitrary element we had fixed. Then we are collecting all the points, and this is what definition of equivalence class that we did in previous question. Set is given as all B belongs to A, such that B, P are related, or else BP belongs to R, right? What does this mean? B belongs to A when distance of OP, distance from center to B, is same as distance from center to P, right? Now we are collecting all such points. Okay, so let's see how we'll do further. Okay, let's make a diagram also so that you will get it more. So this P is some fixed, and we are collecting all such B whose distance from origin to B is same as distance from, that is OB is same as OP. Now this B is in plane, right? So first of all, this is x-axis, this is y-axis. Okay, so how B will look? As B is an element from plane, it will be some point x comma y, right? So now I think you would have studied in your physics or somewhere, maybe in 11th, that how you calculate distance from origin. It is given by modulus. And how you calculate modulus? Modulus is given by this x minus 0, as this point is 0 0, x minus 0 square plus y minus 0 square, and this is x square plus y square. So you are taking B from A, right? So you can write B as B is from A, right? So it will be x comma y type, some x comma y belongs to A, and OB will be then under root of x square plus y square equals to OP. This OP is fixed, right? This OP is distance. It will be also of type this, but this P is fixed. This P is fixed, hence this distance is some fixed distance. So by this what we'll get is x comma y belongs to A, such that if we square both side, we'll get x square plus y square equals to OP square. Now this is what definition of circle. So we are having all such point from the plane such that x square plus y square is OP square, some radius r. So we are having all such point from planes such that x square plus y square equals to r square. So this is what definition of circle is. It is a collection of all such points such that distance x square plus y square, all such x comma y from plane such that x square plus y square equals to some r square. This is what definition of circle means. So we had shown that S collection of all points from the plane which are related with P will form a circle. How we had shown that we had first taken arbitrary B from the point, we had write the definition of that set, that is collection of all B belongs to A such that B and P are related. But what does this mean, B and P are related? This means that distance from the center to B is same as distance from center to P. So now what will be distance from center to B? It will be under root of x square plus y square, where B is some point x comma y, right? B is equals to x comma y, or else you can write it here, B is equals to x comma y. While writing this in bracket, this means that you are giving some reason. Okay, so B is some x comma y. So you had shown that under root of x square plus y square is OP. This means that x square plus y square is OP square, and this is the definition of circle. So we are done. Yeah, so today we did some very good question of the exercise. You should do it properly. This can be asked in exam. Okay, so thank you. This much for this video. We'll meet in the next video with some more questions. Yeah, so thank you. Have a good day.